paradise and put up a parking lot with a pink hotel, a boutique, and a swinging hot spot. Don't it always seem to go that you don't know what you got till it's gone? It'd be a paradise and put up a parking lot.
Hey y'all, this is Dawson here, and today we're going to be looking at parallel and perpendicular lines. So trying to figure out how to write parallel and perpendicular lines to a given line or a given equation. So how can I find the equations for those lines? Let's take a look here. First, let's start off with an equation. Y equals 1/2 x minus 4. That's our equation we're going to work with, and I graphed the line already here for us. And we can kind of make sure this is the correct line by looking at the y-intercept. It's -4, and that y-intercept is right there at -4. And then 1/2 is our slope, rise of 1, run of 2, and that is consistent the whole way along here. Rise of 1, run of 2, rise of 1, run of 2. So this does look, and it's positive. It's a positive slope. It goes from left to right. So we know that this is the equation for that line. So now how would I find something that is parallel to that given line? So if I was if I had to do it just by graphing, then I might just draw another line, just take that same line and move it anywhere. So this equation right here this line is parallel to this line. And there's the parallel definition of parallel is two lines that go on forever in both directions and never cross, never intersect. And so this is definitely a parallel line, and you can see that my slope remains the same, but my y-intercept changed. So now it's 0 instead of -4. And now it's 1 instead of 0, and now it's 2 instead of 0 and 3. So I could make an infinite number of parallel lines just by changing the y-intercept and keeping the slope the same. So as long as the slope is the same, the line is parallel. All right, well that's cool to know. So let's go ahead and write that one out. As long as the slope is the same, the equation will be parallel. Not with, will. Okay, well that's pretty straightforward. Not too bad. So if I'm going to try to find an equation, I just know I'm going to change the y-intercept, the slope stays the same. Good. Now, what if I want to find something that's perpendicular? And perpendicular, that's a little different, because perpendicular means that the two lines intersect one time only, and they intersect at a right angle. So let's see, I'm going to have to move it over here. So I've got it intersecting now, but that's not a 90-degree angle. This angle here is smaller than that. They need to be exactly the same. They need to be 90 degrees to each other. Well, one thing I'm noticing right off the bat is that if this line is positive, then the opposite equation is going to be negative. It has to be. If it's going to be perpendicular to it, it has to be going the opposite direction. So this line's positive and this line is negative. So now, let's see. How do I figure out if it's exactly going to be perpendicular or not? And if it's that's pretty darn close. That feels pretty good. Maybe something like that. It's pretty good. If I have this at this cross point here, and I start looking at my slope, over 1, down 2, that's similar to what we had before, which was, this was up 1 over 2. This one should be up 2 over 1. And so our rise and our run are actually going to get they're going to get moved around a little bit. Okay, so we're going to just adjust that slightly. And now we have a perpendicular line in there. Let's just double check that. Let's bring in a square. Okay. I have to rotate this guy. Move in here, that's 90 degrees. Move it in here and see if in fact we have a 90-degree angle or not. And in fact, sometimes it doesn't always look 90 degree even if it's at an angle, but it is. That is in fact a 90-degree angle there. Hard to tell, doesn't always look like it, but it is. We can check it on the both sides to make sure, and sure enough, that's a 90-degree angle in there. Okay, so we did create ourselves a perpendicular lines, two intersecting perpendicular lines, and the slopes are opposite. So let's take a look at what that means for writing our equation. So for perpendicular, if this slope is 1/2, perpendicular slopes will be opposite. So we know it has to be, because this one's going to be positive, then our new slope will be negative. And here's a vocab word for you, the reciprocal. All right, so now we're going to have the reciprocal of it, and that just means that you're going to flip the rise and the run. So here we have a rise of 1, a run of 2. Here we have a rise of 2 and a run of 1. So we're just flipping them. That's the reciprocal. So in this case, 1/2 is our slope. The perpendicular of it is going to be negative 2 over 1. So I flip it and I change the sign. So that is finding the perpendicular line. Okay, well that's good. To write an equation for a line parallel to this line, but it has to go through this coordinate point. And that's a little bit trickier because we can't just use a graph or come up with any line. Because if I just said write an equation that's parallel, well, it's easy. You just change the y-intercept and you're done. But this one has to go through a specific point, and we have to do some algebra for that. So I know that the equation for the line that is parallel has to be y equals 1/2 x. What I don't know is the y-intercept. That's the part I don't know. I know it goes through this point, but I don't know what the y-intercept is. But remember that this is my x value and this is my y value for that equation. That's one of the solutions for this equation. So if I plug in -7 equals 1/2 times 4, because that's my x value, plus b, I can solve for my y-intercept and get my answer. Multiply across, that's 4 over 2. 4 divided by 2 is just 2. So that's -7 equals 2 plus b. Take away 2 from both sides. And I get that my y-intercept should be -9. So my equation now is y equals 1/2 x, because I know that the slope has to be the same because it's parallel. But my y-intercept now is -9. And that coordinate point, this line will go through that coordinate point for -7. Same thing happens when you want to find the line that is perpendicular, except now I know that my equation has to be opposite. This is a positive, so it has to be negative. And I need it to be the reciprocal fraction, or 2 over 1x. And again, I don't know what the y-intercept is. So do the same thing I did before. Plug in my x and my y up from up here. -7 equals -2 times 4 plus b. This is -7 equals -8. -2 times 4 is 8, -8. Plus b, add 8 to both sides. And I get a +1 over here, and that's what my y-intercept is. So therefore, the equation for the line that is perpendicular, -2x, opposite reciprocal for my slope, plus 1, and that line will go through this point for -7 and will be perpendicular to this original equation that I got. So hopefully that helps you on the work that we're doing here on finding parallel and perpendicular lines. All right, hope all is well and have a great day. See you later.